Learning session. Today we'll solve one of the interesting problem called gold mine problem. We just first understand what is the problem basically. Then we try to solve the problem using pen and paper, or you can think about whiteboarding. Then whatever we solve using pen and paper, we just do the coding in our favorite IDE. I'll use Swift. You can use CPP, Java, or Python, whatever you prefer. And at the end, we can analyze the time complexity and space complexity of the problem. You have given a n by m matrix. So for example, here it is a 3 by 4 matrix. What is the problem here? Basically, a user can go from the first column to the last column to collect the goal in such a way it will maximize it. The problem says like you cannot jump immediately to the down or up. You have only three options. You can go immediate right, or right up, or right down. Basically, for each move you have only four movement. Basically, for each move you can traverse from one column to the next column. So you see the pattern here, like once you start from the first column, we choose 2, and then next definitely you should choose 6, then 4, and then 6. The overall cost will be 18. In the entire problem, you can think about if we take a sub path, for example 2, 4, and 6, this is also optimal. So this pattern is really useful in our dynamic programming problem. So you can solve this problem using DP. Let's solve it first. You can think about, we can traverse from left to right in the first solutions. So we are traversing through column 0 to column n minus m minus 1, and while in the column 0 you can see like we have 1, 2, and 0. So it is like you can think about like 1, 2, and 0, that is a as a starting point, and we create a lookup table basically here. And for the next cell, for the next column itself, where the 3 comes here, now who should be the best candidate for this 3? Now for this cell, you can think about 1 comma 2. In that cell particularly, 1 has the maybe we can reach from 1 to that cell, or we can reach from 2 to that cell also, but there is no scope because there is no up section is here. So we can think about like, okay, if we reach from 1 to 3, what should the value, or what should the cost? It will be 4. If we reach from 2 to 3, it should be 5. So who is the maximum one? We are gaining from 2 to 5, so it should be 5 basically. So I am writing here 5. Now for this cell, because right now we are processing this column, so for this cell you can think about who should be the candidate. We can reach from 1 to here, 2 to here, or 0 to here. But who is the maximum among them? 2 should be the maximum among them. So what should the cost? As we already have 1, so 2 plus 1 is 3. Similarly for this cell, who is the candidate? We can reach from 2 to here, we can reach from 0 to here, this particular cell. So what should be the maximum between 2 and 0? It should be 2. So the cost value will be 8. Now exactly same for here. For this particular cell, we can reach from 5 or 3. Who should be the maximum one? The 5 should be the maximum one. So as the cost value of this mine is already 3, so we choose from the 5. 5 to 3 is your 8. Similarly for this candidate, we have 5, 3, and 8. Who will be the maximum one? 8 will be the maximum one. So as 8 is maximum, what is it? Its cell value is 12. So we can say the overall value is 4 plus 8 is 12. For this candidate also, we can reach from 3 to here or 8 to here. What should be the value maximum of 3 and 8? Is 8. So the overall value is 12. So you can see in the final column we choose the maximum one. You see here is a tie basically. Either you can tie 12 and 12. So you can think about this 12 is coming from which path? It is coming from 2, 8, and 12. So it is nothing but 2, 6, and 4. This 4. And this 12 is also coming via 2, 8, and 12. So 2, 6, and that 4. So it is we can think about there is a 2 solutions, and it is up to you like which one you should throw. Basically we go via FCFS, so you can just choose 2, 6, and 4. Okay, let's jump to the code for this problem, whatever we show right now. So you can see we provided a matrix that is 1 3 3 2 1 4 and 0 6 4, exactly the same matrix whatever I gave. Now this is the overall code. As we are traversing from left to right, so we created a look of two-dimensional array. So I'm using Swift here, and that is really popular language in general and easy to understand also. What is the matrix? N cross M matrix. So n is defined by what is the number of rows, and m is defined by what is the number of columns basically. So we're traversing from column 0 to m minus 1, and we're traversing from row 0 to n minus. For the first time, when we think, we go through the first column itself. Like if you see here, the first column itself, it should be exactly same because there is nothing in the left hand side. So we cannot come from either to left or down or left top. So if the column is first column, the zeroth column, we are always returning 0 because there is nothing for the left, top and down. And for the next column, let's say for the 5, the second column, the first element, for this element I have options. I can come from left or left down, but there is no top, left top. So for that problem you can think about, okay, if it is not column 0, if it is a row 0, that is the first row, there is no top left basically. So that's why it is 0, there is no top left. The same rule is applicable for the down also. If you are at the last row, so there is no left down. So if you are at the last row, there is no left down, so at the time we are returning 0. Otherwise, for any cases, for example, you can think about 3 here. It has options like we can choose left top, we can choose left, and we can choose left down as well. So that is obvious, like we can choose left, left top, and left down. What should be next? We have to choose the maximum among these three. So we choose the maximum among, and then we have to add what is the value it contains basically. For example, here for 3 we choose 2 is here, and then what should be the value? 3 plus 2 itself, 5. Similarly, we have to proceed to the next column in the similar fashion. So at the end we get 8, 12 and 12. Then we have to find out the maximum one basically. So we did the same thing. We find out the maximum one in the last column itself, and we return the maximum value basically. So if you run these applications, I'm just commenting out this one because this is the other way, and this is we are going by left to right. You can see this is the input matrix, this is the output matrix, what we got right now, 1 5 8 2 3 12 and 0 8 12, the same thing, and we find out that 12 is the maximum value among them. In a similar fashion we can solve it by traversing from the right to left as well. Please check my code written in the GitHub, and I'll share the link in the description. Let's think about the time complexity and the space complexity of the given problem. It is obvious that we have to traverse each and every element from the first column to the last column, so the time complexity is order of n square. As it is n by m matrix, so it is order of n by m, and we need the lookup table, so we need the space complexity of order of n square, the same way order of n by m, as it is a n by m matrix. Please subscribe my channel and put a like button. If you have any questions, please put in the comment sections so that I can just know you in a better way. And for getting the more exciting problem solving questions, please subscribe and stay tuned.